Well, welcome back to ENGI307, Data Analysis and Machine Learning. And so this is our final lecture when we're going to be bringing together the 6 different methods that we've talked about in this course, and then started to thinking more about the general takeaways and how we can be using this as we go forward, thinking about exploratory data analysis and data transformations. So let's go ahead and get into that. And this has actually been quite interesting, this material, and I'm hoping both with the project that you'll be doing with this course and things that you'll be doing after this, that you'll find a place for using this kind of information in some very fun and creative ways. So what we're going to do here is we're going to provide an overview of the application of machine learning. We'll talk about data exploration to improve the success of data mining. We'll talk about data visualization to communicate the data clearly. We'll talk about data cleansing in an attempt to fill in missing values. And finally, principal component analysis. And so the major parts of the set of charts that I have here will talk about data exploration, data transformation, and finally, we'll finish up with a few charts on principal component analysis. So here is a chart from our textbook on the analytics and the related subfields that are found in each. And so analytics is, quote, the term for data-driven analyses employed in the decision-making process. Analytics refers to the application of different methods of analysis of data to solve problems. Analytics is data science, processes and techniques to obtain information, analyze it, forecast action towards a solution, and quantify the impact of decisions. So here are the type of things that we can have. The 2 top level categories are business intelligence and predictive analytics. Below business intelligence, you can have queries, report, monitoring, and alerts. Statistical method data and data visualizations. So those would be things under business intelligence. And for predictive and analytics, you can have descriptive modeling, predictive modeling, and optimization and simulations. All of that is based on the different data that we're pulling that in to doing these different types of analyses. So what should one look for when exploring data? The answer to that, there is no trivial answer. Data summaries, correlation analysis, and data visualization via graphs and plots bring out the characteristics of data that will guide in the data mining process. And so that's always a good place to be starting. Exploration is thus an exercise to bring out something new, unknown to the miner, which can then be exploited to improve the success of data mining. Let's talk about basic statistical description. Basic statistical descriptions can be used for getting familiar with the data and their characteristics, such as identifying noise and outliers. The mean, median, and mode can help to identifying, quote, where do most of the attributes fall. Second aspects of statistical description is to have an idea of the dispersion of the data. The most common data dispersion measures are variance and standard deviations of the data. Correlation analysis is used to find the redundancies in the data. Next, we have data visualization. Data visualization aims to communicate data clearly and effectively through graphical representation. Visualization techniques help to discover data relationships that are otherwise not clearly observable by looking at the raw data. For huge data sets, say for 1 million points, it is common to draw a random sample from the data and use it to generate visualizations to make it more interpretable. For data cleaning, now we're getting into data transformations. Real world data tends to be incomplete, noisy, and inconsistent. Data cleansing routines attempt to fill in missing values, smooth out noise, while identifying outliers and correct inconsistencies in the data. For missing points, the possible reasons could be malfunctioning measurement equipment, changes in experimental design during the data collection, human errors in data entry, and deliberate errors, say respondents not willing to divulge information. In the instance of in the number of instances with missing values is small, those instances may be omitted. Replacing missing values with an imputed value, such as the mean of the variables across all samples, is one possible way of filling in that data. For noisy data, data is a random error or variance in a measured variable. Various smoothing techniques are employed by commercial tools available for cleansing the output. For outliers, inaccurate values resulting from measurement errors, data entry, or the like, inaccurate values often deviate significantly from the pattern that is apparent in the remaining values. For identifying the outliers, clustering techniques, data visualization technique, those are some valuable ways of helping with that. So to finish up with data transformations with a couple of slides, for derived attributes, this is the art of making the data mean more. Define new variables that express the information inherent in the data in ways that makes the information more useful. So thus, this is a productive result, and then you have something that's more meaningful. You can have standard numeric variables. You can have normalization of the data to lie in a fixed range. You can replace categorical variables with numeric ones. Random enumeration creates spurious information that data mining algorithms have no way of ignoring. A popular approach is to create a separate binary variable for each category. You can have discretizing numeric attributes. Some classification and clustering methods deal with categorical attributes only and cannot handle one measurement on a numeric scale. To use them on general data sets, numeric attributes must first be discretized into a smaller number of distinct ranges. And then finally, attribute reduction. Principal component analysis is a useful technique for reducing the number of attributes in the model by analyzing the input variables. It's very valuable for highly correlated data. It provides a few new variables that are weighted linearly, or weighted linear combination of the original variables, and it does not use the target variable. Okay, I'll go ahead and stop the video here, and then I'll finish up with principal component analysis.